Hi everybody, got another flipped lesson video for you here today with MCA review that you're going to take notes right along with me on. It's called Patterns in Algebra. We've already done some algebra review. This one's more about patterns, and really when we say patterns, it's going to have to do with using formulas and then using all of the number sense things that we've learned this year to kind of execute formulas, especially as it relates to algebra and even geometry. So the key word here is kind of formulas, and a couple times we've used some formulas that we haven't even realized we've been using, and that's the case in this first one. So the first one I call the DIRT formula. It's D equals R times T. DIRT, get it? And the D, we use this one a lot in the unit that we did before spring break, the chapter 9. The D stands for distance. The R stands for rate. And the T stands for time. We used it a lot, and we didn't even mention this formula because we were finding rates, and we found rates by taking distance divided by time, and that's kind of another iteration of this formula. But that's the DIRT formula, and so if you are given any of those things, you're able to use and solve for either distance, rate, or time. Like I said in chapter 9, we solve for rate. So let's say that that you're driving at 30 miles per hour. And you drive at 30 miles per hour for a total of 0.5 hours, or 30 minutes. What's your distance? This is an example of a problem we did exactly in chapter 9. You had problems like this on the test you took right there before spring break as well. So the formula, and like I said, we didn't even announce the formula we were using. Distance equals rate times time. We're trying to find distance. Distance is right there. Rate is going to be our per word, which should be 30. And then in this case, time is hours, which is 0.5. Now, if we think about this from a unit standpoint, we're taking miles per hour times hours. And so we think about it, 30 times 0.5, first of all, is 15. But if you look at how this works, the hours cancel out here, the hours cancel out here, per is just extra, and so the thing that's left is miles. That automatically is what your label is, miles. 15 miles is how far you'd be. That's a little example of how that one works. You're going to see some other examples, but again, this is just a little flip video, kind of flyover of these things, but I wanted you to get this formula down and just see one little example of how that works. Some other formulas that we've dealt with a lot this year that'll be a review for you have to deal with circles, so kind of transitioning into some geometry. So if we write down circles as our next heading, there's two big formulas that we've dealt with our circles, and that's the area formula. And if you remember, that area was equal to pi times radius squared. And then our circumference formula, and the circumference is pi times the diameter. Draw a picture of a circle out next to the side there. It's been a while since we've done circles, and we'll do a whole lot next week when we come back. It'll be kind of our geometry week. When you think about that, that's a radius. If we continue it all the way across, then that whole thing all the way across there is the diameter. Remember, the difference between that radius is half of the diameter. Another way to say a diameter is twice as much as the radius. And so both of these formulas, I just want you to get down pi times the radius squared for the area, and then under that one, or off to the side where you got some space there, just make sure that you use PEMDAS. If you don't use PEMDAS, right, by meaning do the exponents before, right, square the radius before you multiply it by pi, obviously you're not going to get the right answer. Circumference easy, just take pi times whatever your diameter is. So we'll just do one little example of each of those, and so below that, draw a picture of a circle. You know, I've been meaning to tell you, I probably should keep my voice down a little bit. I'll come a little closer. This class is actually my favorite class. I know you're probably thinking, I'm sure he says that to all the classes, but I really mean that. You are my favorite class. So now that we've gotten that out of the way, on this circle here, make a diameter of 12 inches. We're going to find the area for this circle, and we're going to find the circumference for this circle. So the area, remember, is pi r squared. Well, if that whole thing is 12, that's the diameter, then think about it. The radius is going to be just half of this distance from here to here. Half of 12 is 6, so radius is going to be 6 inches. So here's where we're going. Pi times 6 squared. Remember, instead of pi, we're using 3.14, so I'm just going to drop that down. Now remember, exponents before multiplying, 6 to the second power is 36. Now, 3.14 times 36, I'm just going to pop that in here. 3.14 times 36, and that's going to be 113.04. Now, test taking tip here. We got units, right? If this is a multiple choice question like our old MCA test, they're going to probably give you 113.04 inches as an option and 113.04 inches squared as an option. Remember, anytime it's an area, we want those units to be squared. So make sure you see the squared one. So there's area. Circumference, we take pi times the diameter. We got two options here. 6 is our radius, 12 is our diameter, so make sure you correctly use 12. So this will be 3.14 times 12. Type that guy in. 3.14 times 12. 37.68. Now another key important part, circumference is just how long it is around, how far it is. So that's just inches without a squared distance instead of space inside. Okay. All right. I'm going to have you do a little check-in and see how we're doing here. I'm going to give you one little sample problem right below there. I'm going to have you label it problem A. And we're going to use our dirt equation. So let's say that Sam biked 14 miles per hour for 2 hours. Question I want you to find out is how far is he? Second question I want you to do, we're going to label it part B. I only want you to find, I only want you to find the circumference for that circle right there. I won't say anything else other than copy that guy down and find the circumference. All right, pause the video, work on those two things. All right, let's check in and see how you did. So the first one was the distance equals rate times time. The rate is 14, the distance is 2. 14 times 2 is 28. 28 miles. Make sure you got the label on there. Circumference of that, I gave you a radius, so you had to think the diameter is 10. Pi times 10, 3.14 times 10, that's 31.4 centimeters. Without the squared on it since it's the distance. There it is. All right, in our last little topic here, I just want to go one more little short topic. It'll be all about rates and then tables. And we haven't done a lot of this work. You did a lot of this in 6th grade. We did some of this at the beginning of the year, but it's all about making tables. So make a heading there that says tables. These would be the mathematical tables involving X and Y. I'm going to show you one sample problem and then that'll be it. So let's say that we've got someone earning money at a job, and they come into the job wanting to make some extra money. So let's say that you already have a whopping $40, but you get a job and you earn $7 per hour. So what we're going to do is make a table about this situation, and we're going to have our independent variable and our dependent variable, if you remember those words from your 6th grade year. And the one here that's independent is hours. Independent means it's going to happen no matter what. No matter how many hours or no matter how much you work, hours is time, is just going to keep moving all along. Our dependent variable is going to be our money, because money depends on hours, right? How much money you're making based on your rate depends on the hours. So I put them in that way. Put a little X above hours, put a little Y above money, and then I didn't leave myself a lot of room here, but put independent above X and dependent above Y. That's a good little thing to remember. The X value is always going to be independent. Y value is always going to be dependent. We're going to make a little table here from 0 up to 4 hours. So when you've worked 0 hours, how much money do you have? Well, you still got your $40. So 40 goes there as 0. Then with every hour that you work, you're earning $7 per hour. So after 1 hour of work, you now have a total of $47. After 2 hours of work, 47 plus 7 is 54. You have $54. After 3 hours, add another 7 onto that. That's at $61. And after 4 hours of work, add another 7 onto that. You're going to have $68. All right, so it's a pretty simple pattern to see. Remember, this is kind of about patterns in algebra. And we talk about this as being its rate of change. So if I said, all right, what's the rate of change in this table? And you didn't know any of the other information about this, you'd have to look at this and go, wow, it's going up 7 every time. 7 every time, therefore its rate of change is 7, or $7 in this case. So that's a key word, kind of an important thing to learn. You're going to actually in algebra learn about rate of change and then how that evolves into what we call slope. But think about this, if we were to graph these, we had a homework question several weeks ago, you may remember, about ordered pairs. These would be ordered pairs, 0, 40, that'd be the first point in our graph. I'm just going to skip another last one, 4, 68, that'd be another point on the graph. And this would make, we're not going to officially do this, but this would make a perfectly straight line, which we'd call linear. Just if we make a little sketch that would kind of go up like this. Because its rate of change, which you're going to learn about is rise over run, goes up $7 for every 1 hour. So that's how that would kind of look in a graph. You're going to see some of these tables in the work that you do today, and that'll wrap it up. All right, have a good rest of your day. You're going to get this patterns packet now, and that'll kind of keep you busy for the rest of the hour. All right, thanks everybody.